In this video, we'll use some of the molecular properties we calculated earlier to build a predictive model of binding affinity. After building that model, we'll go ahead and plot the results. If you're watching this video, you're probably already well acquainted with partial least squares regressions, a statistical method that has its own entry under the Applications menu. To get started, we'll click on that entry and open up the PLS regression interface. The first thing we'll want to do is to specify the name we'll use to save the model that we build. Let's call it PLS example. Next, we need to choose the dataset that we're using to build and assess the model quality. In this example, we'll choose to use all rows. After choosing to use all rows, the table in the lower left-hand part of the interface is populated. We also need to choose our x and y variables. In this case, we'll use the experimentally determined activity as the y value, and everything else, namely the results of a previous Canvas molecular properties calculation, as the x variables. Initially, every single compound is to be used as part of the training set. In other words, every single compound and its associated properties will be used to build the model. In this example, we want to split our compounds into a test set and a training set. That is to say, we want to use a subset of our compounds to build the model, and the remaining subset of the compounds to assess the quality of that model. This is almost embarrassingly easy to do. We'll just click Assign Random Training Set, and by default, half of the compounds will go into one group, and half will go into the other. As you can see, things are split up randomly. If we want to enforce a reproducibly random selection, we can use the seed field to specify a specific seed value that's used to generate the random selection. In this example, I'll also increase the number of PLS factors from 1 to 3. Finally, to create the model, we'll click on the Build Model button at the bottom of the interface. After the model is built, we can see an overview of the results in the lower right-hand corner of the window. There are two tabs here, one for the test set and one for the training set. The Training Set tab has a variety of statistics to help us evaluate the model quality, with statistical terms like standard deviation, R-squared, and p-values in the columns. Each row contains results for a model with a given number of PLS factors, and scanning downward through the rows reveals how the model quality changes as we add additional PLS factors. The Test tab is very similar to the Training tab, but it has fewer statistical terms. Of course, one of the first things that you may want to do after building a model is to create a scatter plot that you can use to visualize your results. Clicking the Scatter Plot button allows us to go ahead and do so. Here we can choose which compounds to plot: the training set, test set, all of them, or a custom subset, and we can specify a few additional options. To display the plot, we'll just click Scatter Plot. Looking at the plot as it appears with default options, we can get a rough idea of how well the predicted activity correlates with the experimentally determined activity. All of the usual controls for dealing with scatter plots can be used here, but in particular, it's useful to remember that we can hover the mouse pointer over individual plot points to see the corresponding 2D structure. After building a model, you'll probably want to use it to perform property or activity predictions on other compounds. After you've imported those other compounds into Canvas, you can use the PLS interface to do just that. All you need to do is choose to apply a saved model, as shown here. If you think that a model you've built is good enough that you'll want to repeatedly use it, go ahead and use the Export Model button at the bottom of the interface. Then, when you're working with novel compounds and other Canvas projects, you can use the Apply Imported Model setting to use your saved model. Now, let's take a look at how to perform a partial least squares regression and view a scatter plot of the results of that model in a live demonstration. To get started, I head up to the Applications menu, and I choose Partial Least Squares Regression. This opens up the PLS interface, which is very easy to use, and to get started, we just make sure that we're operating on all rows in the table instead of selected rows, and I'll save the results as PLS example. The next thing that I'll do is choose the X variables that I'll use to build my model. In this case, I'll choose everything but PIC50, the activity property, and I'll just shift-click to highlight those in the X variables list. And under Y variable right here, you can see we've got this drop-down menu. We can choose from any of the columns in the table, and here I'll just choose the default, which is activity. So finally, I'll just show you how to increase the maximum number of PLS factors. And finally, to assign a random training set, I'll just press the Assign Random Training Set button. You can see that about half of the compounds in the table now have a check mark next to them in the training set column, and half of them don't. And what this means is going to become clear once we build the model. So I'll just press Build Model to go ahead and do that. And you can see that we've got results for both the training and the test set right here. Now the results for the training set are the results for the model that was built using just the training set. In the test set, those compounds for which we don't have a check mark in this column right here, for the test set, Canvas is going to go ahead and predict the activity, the PIC50 value, for those compounds using the model that was created with the training set. So we can see the results here in the Test Set tab. Next, I'll show you how to go ahead and export the model. Very simple to do. Just click Export Model, and we can save this PLS model to disk. This is very handy if it's something that's kind of generic that we might want to be applying across different Canvas projects. Now I'll cancel that right here for this example. The next thing I'll show you how to do is how to apply a saved model. Now a saved model is different than a model that was exported. A saved model is actually just something that appears here within our Canvas project already. You can see it in the project view pane. PLS example appears under the PLS listing right there. So you can see that next to the Apply Saved Model option, we've got a drop-down list of, in this case, the one saved model that we've built within this Canvas project. Under Apply Imported Model, we can press this toggle to go ahead and import a model that we had exported to disk previously. This could be a model that was built in an entirely different Canvas project, for example. So I'll press Import to bring in a previously saved model, and I'll choose this one, PLS_MW. And this is a model which is going to predict IC50 values based on the molecular weight of the compound. So I'll press Import, and all I need to do is press Apply Model once I've imported that saved model. And here you can see that we've got results in the Test tab and the Training tab right here. And I'll go ahead and take a look at what the results of this model actually mean by clicking on the Scatter Plot button right here. This gives us a few options, so I'll just press Plot to go ahead and plot that model. And you can see here that we've got predicted activity and the activity right here. And it's not the best model in the world, but you can see what the results actually look like.